Like, so you got to switch your brain back to tests. And this is one of the things I'm looking for is you guys to understand what the difference is between an interval and a test at this point, and then how to start that. And I think once you get the start bit down, the rest of it kind of flows out. So chapter 11 is about tests for means. It's the last one of this 4-chapter set. Chapter 12 is different, but the same. Different, but the same. It's not, at least there's something new for me to teach you in chapter 12. Chapter 11, not so much. I feel like I could stay home for all of chapter 11 and you guys could figure it out, but that's okay. Nothing wrong with that. So when you're doing a test, I want to focus on the word test here. What do you start with in your state when you do a test? I'm looking for 4 things. The hoe, right? Great job. Okay. Yep. See all the things that you know. Okay. Mu. Okay. That's the big thing. So you're so used to putting P equals, and now we're at mu equals. And so you're going to have mu equals a number. It's not going to be a decimal typically here. So you're going to have to get used to the fact that it's not a proportion. It's going to be like 5 or like 17.6 or something like that. And then for your Ha statement, greater than, less than, or not equal to again, depending on your wording of your problem. And then you have mu equals the true means something. And then alpha equals 0.05 or given to you in the problem. So if it's given to you in the problem, you use whatever they give you, but if not, then you've got nothing to go on. You go with the middle value, which is 0.05. Okay, so what's the big difference here? Just remembering to use mu, and it's the true mean. And don't get weirded out by the fact that these are going to be not decimals because you're so used to working with decimals there. Everybody good with that? Okay. Inference method, 1 sample t-test from you. This is a perfect thing for us to do on a short day because it's kind of ridiculously easy. Okay, now random. You use the wording from the problem, or you assume if you're doing an FRQ. If you're doing an MCQ and they're asking you about the conditions, you don't assume anything. You go back to the wording of the problem and say it didn't say random, so the random condition's not met. If you're doing an FRQ, it's a 4 to 5 point question. You're not going to stop on random and get, 3 points off. This is what you would expect, correct? Okay. %, conditions. Anything new there? One of the things I want to talk about what from the test real quick that I just passed back. As a lot of you guys got the 10% condition incorrect. We got minus a half point on the 10% condition. And that's because the population was all adults who entered college. Okay, and it was not about college freshmen. That wasn't the population. Okay, and I want to talk to you about this real quick. If you want to find out who finished college, then you ask people that are in college. No, it doesn't make sense to ask somebody while they're still doing it. You wouldn't ask a college freshman if they finished their freshman year. You don't know. That's why the population was all adults who entered college. You have, it's like a past situation, but they can't answer the question till it's over. So you guys just need to, I think in that case, we're trying to analyze the problem instead of just reading off the. So you're gonna have to, I'm never gonna tell you to do this, but you gotta lower your brain power, like just a notchy, and just copy straight off of what the sample was of. Okay. Just wanted to mention that as we're passing the test back today. And then I can't remember who it was. Somebody was like adorable and put extreme really big on their team test that I stamped yesterday or Wednesday. It was so cute. I loved it. It made me happy. It reminded me of the Slim Jim commercial I was hoping for. Okay. I don't think any of this is rocket surgery at this point in the year. Oh, rocket surgery is a really, really important level of science where you're doing brain surgery and rocket science at the same time. Yeah, I mean, it's for the elites. It's actually just a joke. Anyway, okay. All right, now the Dewstead. So you guys, your brains are in interval land. I know they are. That's okay. I want to remind you about this bit right here, standardized test statistic. And I want you to add a couple of notes to your yellow sheet here. In chapter 9, you were doing proportions, so your standardized test statistic was Z equals. And in chapter 11, you're doing means, so your standardized test statistic is T equals. None of this stuff changes. It's just that you're doing T equals. Okay, so add this bit. I have a quick question. Why do we have to use T? You don't have something. Yes, you don't have population standard deviation. If you have to use S sub X, which you're going to have to do, unless your teacher magically gives you sigma on the team test to make you think about that statement on, say, number three. Number three. Yeah. Okay. T equals. Okay. Now, what would the statistic be for something to do with means? What's a statistic for means? X bar. And if you're ever not sure, you could find it right there. Okay. What's the parameter for means? It's whatever you put in the hoe, mu equals. Okay, and then standard error of the statistic is going to be this guy, S sub x over square root of n. And then, where do I want to put it? I don't know if you guys noticed, but there's a TCDF. And TCDF is low, high. So yes, you're going to have to figure out which is which. It's not the same rules as normal CDF, but it's not 0, 1, it's degrees of freedom. Degrees of freedom is still n minus 1, as you would expect. Okay, since our p-value of something is, and I lined this up so all the 3 on the top go together and all the 3 on the bottom go together. Since our p-value is less than alpha, we reject the ho. We do have convincing evidence. And then this is the ha or the wording from the problem, whichever makes more sense. And when I say ha here, I mean in words. And then since our p-value of something is greater than alpha, we fail to reject. We do not have convincing evidence of the ha. None of that is any different. It's just going to be true mean instead of true proportion. Okay. Now, it looks like, I have this example here, and I broke it up into 4 equal pieces. I bet you can't guess what the 4 pieces of the example are. I bet you can't guess. I mean, it would be weird if I did say A was the state, and B was the plan, and C was the conclude, no, was the do, and C is the conclude. It's like in this section, they're trying to make you feel like you're doing something, you're doing it in pieces for some reason, but it's just the thing.
You're taking every. Wow. I've been started, I'm like, worried. It's like Apple. Yeah. So I have to go and then. All the players. We can use freaking. We don't really hang out. If I can. So it's with their first name, their nickname. Yeah. So they can. It's so good. Get your night English.
Oh, what's that? But I don't know about that. Yeah. Yeah. I think me all. I think that.
But that's not. Okay, so four things, we need four things for the state. This is just asking you to do the state step. For some reason, instead of just saying do the state. But that's what they've decided they want us to do here. Didn't you make this, Mrs. Talbot? Kinda. But I went according to the book. The makers of Aspro brand aspirin want to make sure their tablets contain the right amount of active ingredient. They inspect a random sample of 30. Yes! Are you excited that it's 30? I'm excited that it's 30. Tablets from a batch in production. When the production process is working properly, Aspro tablets contain an average of 320 milligrams of active ingredient. The active ingredient in their sample has a mean of 319 and a standard deviation of 3. Okay, so I know from, watching Mrs. Talbot's, exciting previous work here on today's notes, that I'm going to have a ho and a ha. I'm going to have to say the mean equals something and alpha is something. And I know from watching those exciting, riveting notes from earlier that my ho is going to be mu equals a number. But here's my question for you. I don't understand because I'm just new to AP statistics over here. Oh, yes, so new. I don't know which one of those numbers is mu. 320. 320. Okay, remember, the ho is the statement of what's happening currently. No change, nothing's going on, original claim. Or you can think about it as a population, like all, right? And this one definitely is not because it says sample. So you can rule out these two guys because they said sample stuff. And then that guy's N, so it's got to be that guy. Okay, anyway, let's see. Does it say anything about increase or decrease or more than or less than? No, it just says the right amount. So what's that? Not equal to. So what are we going to do at the end? Nice. Nice. Look at you. Okay. Mu equals the true mean what? Amount of active ingredient? And they did not give me an alpha level, so I'm going to go with the middle of the road, 0.0. Okay, any questions about that before we move on? Does it seem like what you think it should seem like? Okay. The great thing about this section is there's nothing weird. Like there's no like, but when you have this, you use this formula. It's not like that. It's just straightforward. Okay.
Sorry, guys. I just wanted to tell you I'm gonna put, I know it's shocking, but we're gonna use those for chapter 11. Try to hold your shock in. Um, so put chapter 11, which is not bankruptcy in this case. Another joke, Mrs. Talbot. Uh, um, put chapter 11 next to those two. And then if you came in late, we also added a note to the front that, that's T, you got it, okay. That T equals instead of Z equals that. Okay, anyway, sorry. I think that's everything for the whole chapter already. We're on the first day and like, we already labeled the whole deal. I also have a joke for you that I'd really like. Maybe I wrote something wrong. You're just waiting for me? Okay. All right. B, check the conditions for carrying out this test. Gosh, that sounds a lot like the plan. Hi. That's good. They're attentive and also asleep. Thank you. I know. Now, it didn't really ask for this, but I just like to get in the habit. I'm sorry, whatever it is I'm keeping you from. Okay, was it random? I forget. My short-term memory problems. Let's look. Random sample. Great. And N equals, this is going to be a really big test for you to be able to identify the population. N equals 30 is less than 10% of all. What is the sample of? Tablets from a batch in production. Oh, it says from, whatever. Okay, now what if this was a proportion situation? What would you do for the large counts? N times P, N times 1 minus P. What if it was two sample proportion? Cooled. Nice. Nice. Oh man, you're on fire. Okay. Sorry, I'm just reviewing for the AP exam early. Calculate the standardized test statistic and p-value. Gosh, that sounds like the do step. T equals. Okay. T equals, what is the statistic in this problem? Sample mean, which is 319 minus the parameter is 320, that's mu. I'm thinking this is probably going to fail to reject because the difference between those two is so small. Hopefully you guys are starting to pick that up. 3 over the square root of 30. This is another time where you need to be really careful about how you enter this in the calculator. If I don't do this in one swoop, you can if you like. I hit enter after the top, and then I divide by 3 divided by square root of 30 in parentheses. This is, except for that I did that wrong. In parentheses is this. A lot of people, especially in fifth period, I don't know, I noticed them on their whiteboards. They were like calculating each of these pieces off to the side and then plugging them in, which is totally fine too. Just make sure that you're getting the same answer as me, which is going to be negative 1.83 in this case. And what are the degrees of freedom in this problem? 29. Just show you TCDF. It's located right next to all your other friends in your calculator. Look at them. They're all in a group together. Oh, what was I messing with? Oh, I was wrong. No, I wasn't. Do you guys know why I wasn't wrong? Yeah. Failed to reject. So sad. Okay. Now, this is one of those cases where it didn't really give us like wording. It didn't say, like the question didn't say, do you have convincing evidence of blah, 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 something? So we have to go back to the original problem and take the ha and rewrite it in words. So I'm going to scroll up here. What would the words be for the ha? What goes here? The true mean amount of active ingredient is not 320. It's a double negative, but that's what it is. Okay, what that means is they didn't find any evidence that they have the wrong amount in their tablets, but you can't conclude that they do. You just didn't find any evidence, you don't find enough evidence to say that they do. So your conclusions be nothing, the sample sizes are small, and you should be, what did he say? Dr. Zoidberg? Remember what he said? Your standard deviations are large, and You remember him, Dr. Thornburg? He's so cute. Okay. Real quick, before you, depart. Hold on. 1 second. Before you depart. Here's my joke. It says, Mr. T says, I pity the fool that doesn't know their population standard deviation. See, but that's gonna help you remember why we have to use T instead of D. Because Mr. T says he pities the fool. Hold on, I'm not even, I didn't even. Okay.